November 8th, 1997, 7:42 p.m. The Scripps Institute, Anderson Auditorium, La Jolla, California. Imagine a great white shark, 50 to 60 feet in length, weighing close to 40,000 pounds. Professor Jonas Taylor looked at his audience of just over 600 and paused for effect. I find it hard to imagine myself sometimes, but this monster did exist. Its head alone was probably as large as a Dodge Ram pickup. Its jaws could have engulfed and swallowed 4 grown men whole, and I haven't even mentioned the teeth, razor sharp, 7 to 9 inches long, with the serrated edges of a stainless steel steak knife. The 42-year-old paleontologist knew he had his audience's attention. It had been several years since he had returned to the Institute. Lecturing in front of a nearly sold-out crowd was not something he had anticipated. Jonas knew his theories were controversial, that there were as many critics in the audience as there were supporters. He loosened his collar a little, tried to relax. Next slide, please. Here we have an artist's rendition of a 6-foot diver as compared with a 16-foot great white and our 60-foot Carcharodon megalodon. I think this gives you a fairly good idea why scientists refer to the species as the king of all predators. Fossilized megalodon teeth from around the world prove that the species dominated the oceans as long as 70 million years. What's really interesting is that we know that the megalodons survived the cataclysmic events that occurred about 65 and 45 million years ago, respectively, when the dinosaurs and most prehistoric species of fish perished. In fact, we have megalodon teeth that indicate these predators disappeared only 100,000 years ago. From a geological standpoint, that's a tick of the clock. A grad student raised his hand. Professor Taylor, if these megalodons were alive 100,000 years ago, why did they become extinct at all? Jonas smiled. That, my friend, is one of the great mysteries in the paleo world. Some scientists believe that the staple of the megalodon's diet had once been large, slow-moving fish, and that they could not adapt to the smaller, swifter species that exist today. Another theory is that falling ocean temperatures contributed to the species' demise. An elderly man raised his hand from his seat in the first row. Jonas recognized him, a former colleague at Scripps, a former critic. Professor Taylor, I think we'd like to hear your theory of the disappearance of Carcharodon megalodon. Jonas checked his watch, realizing he was running behind schedule. Maggie was going to kill him. Very well. First, I disagree entirely with the theory regarding megalodon being unable to catch quicker prey. We have learned that the conical tail fin of the great white, the modern-day cousin of the megalodon, is the most efficient design for propelling a body through water. We also know the megs existed as recently as 100,000 years ago. Then, as now, the predator would have had an abundant supply of slower-moving whales to feed upon. I do, however, agree that the diminishing ocean temperatures affected these creatures. About 2 million years ago, our planet experienced its last ice age. The deeper tropical currents that had provided a refuge for many marine species were suddenly cut off. As a result, many species of prehistoric fish, including Carcharodon megalodon, perished, unable to adapt to the extreme drops in oceanic temperatures. The elderly professor called out from his seat. So then, Professor Taylor, you do believe that the megalodon became extinct as a result of climatic changes? The older man smiled, satisfied with himself. Not exactly. About 15 years ago, I was part of a scientific team that first studied deep-sea trenches. Deep-sea trenches form the Hadal Zone, an area of the Pacific Ocean about which scientists know virtually nothing. We discovered that these deep-sea trenches occur along the edges of 2 oceanic plates, where one plate melts back into the earth by a process called subduction. Inside these trenches, countless hydrothermal vents spew mineral-rich waters at temperatures that sometimes exceed 700 degrees Fahrenheit. So, in some of the deepest, most unexplored locations of the Pacific Ocean, a tropical current of water can run along the very bottom. To our surprise, we discovered that these hydrothermal vents supported new life forms never before imagined. A woman stood and asked excitedly, "Did you discover a megalodon?" Jonas smiled and waited for the crowd's laughter to subside. No, ma'am. But let me show you something that was discovered over 100 years ago, which might be of interest. Jonas pulled out a glass case, roughly twice the size of a shoebox, from behind the podium. This is a fossilized tooth of Carcharodon megalodon. Scuba divers and beachcombers have turned up fossilized teeth like this by the thousands. Some are nearly 50 million years old. This particular specimen is actually special because it's not very old. It was recovered in 1873 by the world's first true oceanic exploration vessel, the British HMS Challenger. Can you see these manganese nodules? Jonas pointed to the black incrustations on the tooth. Recent analysis of these manganese layers indicated the tooth's owner had been alive during the late Pleistocene or early Holocene period. In other words, this tooth is a mere 10,000 years old, and it was dredged from the deepest point on our planet, the Mariana Trench's Challenger Deep. The crowd erupted. Professor Taylor! All eyes turned to an Asian American woman standing in the back of the auditorium. Jonas looked at her, caught off guard by her beauty. Somehow she seemed familiar. Yes, go ahead, please, said Jonas, motioning for the audience to be quiet. Professor, are you saying that the megalodon may still exist? Silence. It was the question the audience wanted answered. Theoretically, if members of the megalodon species inhabited the waters of the Mariana Trench 2 million years ago, waters that maintain a deep tropical layer as a result of hydrothermal vents, then one could logically say that a branch of the species might have survived. The existence of this 10,000-year-old fossil certainly justifies entertaining the possibility. Professor, a man raised his hand. If these monsters still exist today, why haven't we seen them? A good question. Jonas paused. A beautiful blonde woman, tan, 30 years old, her figure flawless, was walking down the center aisle. Her classic topaz evening gown managed to expose her long legs. Her escort trailed behind, 30-ish, wearing a ponytail and tuxedo. The pair took the 2 empty seats reserved in the front row. Jonas composed himself, waiting for his wife, Maggie, and best friend, Bud, to be seated. Sorry, your question was why we haven't actually seen a megalodon, assuming members of this species still exist. First, if a megalodon did inhabit the deepest waters in the Mariana Trench, it couldn't leave that tropical bottom layer. The Challenger Deep is 7 miles down. The water temperature above the warm layer is near freezing. The Meg could never survive the transition through 6 miles of icy waters in order to surface. It's also unusual for megalodon, or any shark for that matter, to leave behind evidence as to their existence, especially in the abyss. Unlike mammals, sharks do not float to the surface when they die, as their bodies are inherently heavier than seawater. Their skeletons are composed entirely of cartilage. So unlike dinosaurs and many species of bony fishes, there are no megalodon bones to leave behind, only their gruesome fossilized teeth. Jonas caught Maggie's eye. It seemed to burn into his skull. One other thing about the Mariana Trench. Man has only ventured down to the bottom twice, both expeditions occurring in 1960, and both times in bathyscaphs. That means we simply went straight down and back up again. The reality is we've never come close to exploring the trench. In fact, we know more about many distant galaxies than we do about a 1,550-mile isolated section of the Pacific Ocean 7 miles down. Jonas looked at Maggie and shrugged. She stood, pointing to her watch. You'll have to excuse me, ladies and gentlemen. This lecture has lasted a bit longer than expected. Excuse me, Dr. Taylor, one important question. It was the Asian woman again. She seemed perturbed. Before you began studying these megalodons, your career was focused entirely on piloting deep-sea submersibles. I'd like to know why, at the peak of your career, you suddenly quit. Jonas was taken aback by the directness of the question. I have my reasons. He searched the audience for another raised hand. Wait a minute, I need to know. She was standing now, walking into the center aisle. Did you lose your nerve, Professor? There had to be a reason. You haven't been in a submersible for what? 7 years? What's your name, miss? Tanaka. Terry Tanaka. I believe you know my father, Masao Tanaka, of the Tanaka Oceanographic Institute. Yes, of course. In fact, you and I met several years ago on the lecture circuit. That's right.